All right, guys, here's some support on question number 12. All right. So, question number 12 says we need to evaluate the left hand side to find the value of A in the equation in simplest forms. All right. So, we need to try to find the value of A. A is the exponent of this equation. All right. So, I need to try to utilize various exponential rules. All right, to try to find what this exponent, all right, will be for A, okay? So here are the exponential rules you guys need to know for Algebra 1, all right? The first rule that you guys need to know is a product rule, all right? So again, the first rule we're going to talk about, guys, is product rule, okay? So product rule states that anytime that you're multiplying things that have the same base, all right, in this case, we're saying that base is x, okay, you are going to add the exponents, okay? So again, product rule states that when you're multiplying things that have the same base, what are you going to do to the exponents? You're going to add them, all right? So x to the third power multiplied by x to the first power would give me x to the fourth power, all right? Similarly, if I saw x to the negative 2 power multiplied by x to the sixth power. Again, when you multiply things at the same base, you add the exponents. Negative 2 plus 6 will give me positive 4. All right? So again, guys, that is product rule. Okay? The next rule you need to know, guys, is the opposite of product rule. That rule is called quotient rule. All right? So quotient rule states that not when you're multiplying, but when you're dividing things that have the same base, all right, you are going to not add exponents, but subtract them, all right? So 2 minus 1 or 2 take away 1 leaves you with 1, all right? Similarly, if you had x to the fourth power over x to the 17th power, all right, you would subtract exponents and this would be x to the negative 13, all right? However, you cannot represent that x with a negative exponent most of the times, so this will simplify to be 1 over x to the 13th power, all right? That negative exponent just means that you write your base as a fraction, all right? So I just actually use two rules right there. I use quotient rule and negative exponent rule. All right. So again, negative exponent rule means that if we have a negative exponent, you write it as a fraction of itself. Okay. So x to the negative 13 is the same as 1 over x to the 13. You just write it as a fraction. All right. And then the final rule, guys. So again, the final rule you guys need to know is power rule. All right. So that's the final rule you guys need to know. All right. Power rule is the easiest rule to use. Power rule states that whenever you have an exponent on the inside and an exponent on the outside, okay, you are going to multiply exponents, all right? So this 3 is the same as 3 over 1, so that when I multiply my numerators, 3 times 3, I get 9. And when I multiply my denominators, 1 times 4, I get 4, all right? So again, guys, those are the three rules, okay? So looking at our question right here, which one of the three rules would I use for my question right here? I would use power rule, all right? Because again, I see an exponent on the inside and the outside, all right? So when I'm using power rule, guys, okay, I'm going to just multiply the exponents, okay? So both of these are written as fractions, okay? So when I multiply the numerators, 1 times 3 is 3, 2 times 5 is 10. Can I simplify 3 and a 10? No. And that is it. So again, guys, once you know these rules, you will be fine. The question says only write A. A is just the exponent, so I don't need to write the x. All I need to write is the 3 over 10. All right? So again, just like that. So let's try another one, guys. Let's try another one, all right? So when I'm doing this, guys, which rule do you think I'm going to use? Product rule, quotient rule, or power rule? Which one do you think? I'm gonna again use power rule, all right? So when I'm using power rule, I'm gonna multiply the exponents, okay? So this is a fraction, 3 over 2. 6 can be written as a fraction as 6 over 1, all right? 3 times 6 is 18. 2 times 1 is 2. And can I simplify 18 and 2? Yes, because both 18 and 2 are both divisible by 2. Okay? 18 divided by 2 is 9. 2 divided by 2 is 1. Or I could have just divided 18 by 2. Alright? So again, guys, the answer would be 9 over 1 or just 9. Alright? But again, you can write it as 9 over 1 if you would like. Okay? So let's try another one, guys. Let's try another one. Alright? So this one is a little different, guys. So which one of the three rules do you think I'm going to use for this question, guys? I'm going to use product rule, all right? Because again, I'm multiplying things that have the same base, okay? So again, I don't see an addition or subtraction sign, so I'm assuming I'm multiplying right here, okay? And whenever we're multiplying things that have the same base, you're going to do what with the exponents? I'm going to add them, all right? So let's add these exponents together. Oh, we're adding fractions, all right? So not a lot of people love to add fractions, but I'm going to show you a perfect way that you guys can use all the time, all right? This method is called butterfly method, all right? So with butterfly method, guys, all right, whenever you're adding or subtracting fractions, the first thing you're going to do is multiply the denominators. And that probably sounds weird that you're technically adding or subtracting, all right, but you're multiplying to do it. But just follow me, guys, because that's how you do when you're adding or subtracting fractions that have different denominators, okay? So I firstly multiply the two denominators. I get 30. Then I cross multiply this way first. Every time you cross multiply that way first. 3 times 6 is 18. Then I cross multiply this way second. All right. 5 times 1 is 5. And then what are we doing? We are adding. All right. So I put an addition sign in between. And you see it kind of looks like a butterfly? Yep, that's the butterfly method. 18 plus 5 is 23 over 30. Now I'm going to see if I can simplify it. Can I simplify 23 and 30 anymore? No, because 23 is indeed a prime number. All right, so my answer for this question would be 23 over 30. All right. So again, guys, just like that. So again, let's keep on practicing, guys, because the more we practice, the better we'll get at this, guys. All right. And if you realize there's a lot of different variations to this question. All right. So let's try another one. Okay. So for this question right here, guys, what rule, because again, we need to know the rule first. What rule do you think I can use to solve this question? Do you think I can use power rule, quotient rule, or product rule? I would need to use power rule, all right? Because again, I see an exponent on the inside and on the outside, all right? So this 2 is the same as 2 over 1. Multiply the numerators, 2 times 3 is 6. Multiply the denominators, 1 times 2 is 2. I can divide, or rather simplify, 6 and 2 by dividing each of them by 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. All right, so my answer for my exponent would be 3 over 1 or just 3. Okay, so again, guys, the more you practice this, guys, the better you'll get at this, because again, it has a lot of different variations. Because if you realize, we haven't even seen a quotient variation as yet. So again, there's a lot of different variations for this one. So which rule do you think I'm going to use? Power rule, quotient rule, or product rule? Product rule, because again, I'm multiplying things that have that same base, okay? So I don't say an exponent for this. So what can I assume the exponent is? A 1, all right? So we're doing 6 over 5 plus 1. And you can write it as 1 over 1. So let's use the butterfly method. Multiply the denominators. I get a 5. Cross multiply this way first. And then I get 6. cross multiply this way second, and I get 5. And then what are we doing? We're adding. 6 plus 5, all right? So again, we're adding, so 6 plus 5 is 11 over 5. And can I simplify an 11 or and a 5? No, I cannot, all right? So again, this would be 11 over 5, okay? So again, the more you practice, guys, the better you'll get at being able to fight your fear of fractions. All right? Because I know a lot of you guys are fearful of fractions, and I want you guys to never fear anything, guys. All right? So again, let's go ahead and let's keep on practicing. The more practice you'll get, you'll defeat all your fears. All right? So here, guys, what rule are we using? Product rule, quotient rule, or power rule? We're using product rule because again, we're multiplying things that have the same base. So 3 is going to, so again, when you multiply things at the same base, what do you do to exponents? You add them, all right? So I will be adding 3 over 1 plus 3 over 5. Get a common denominator by multiplying. It's a butterfly method, all right? We get 5, cross multiply this way first. You get 15. Cross multiply this way second. You get 3. And what are you doing? You're adding, all right? I love the butterfly method, all right? 15 plus 3 is 18 over 5. And can I simplify that anymore? No, I cannot, all right? So my answer is 18 over 5. All right. So let's keep on practicing, guys, because I want to see one where it's a quotient, guys. All right. Because I haven't seen a quotient this entire time that I'm doing these problems. All right. So let's try to do some more until we see a quotient rule. If not, we're just going to have to use the example that I wrote on the board. Okay. So for this one, guys, what rule am I going to use? Product, quotient, or power rule? I'm going to use power rule, all right? Why am I going to use power rule? Because I see an exponent on the inside and on the outside, okay? So with power rule, we're going to multiply the exponents, all right? And again, don't get confused with product rule, okay? So again, when you're doing this, guys, when you're multiplying fractions, all you do is just multiply the numerators, all right? So I multiply the numerators, all right? And now we get 4. Then I multiply the denominators. So I multiply the denominators and I get 10. Okay? So this can be simplified a little bit more because both 4 and 10 are divisible by 2. Okay? 4 divided by 2 is 2. 10 divided by 2 is 5. So my answer is 2 over 5. Okay? So again, if I don't get a quotient one after this, guys, we're going to have to just go with the example that we have. And we're lucky, guys. We are lucky. All right. So let's do this one, guys. We are lucky. All right. So we've all been waiting for it, guys. So what rule are we going to use for this one? We're going to use quotient rule. Finally, right? So again, with quotient rule, whenever you have things at the same base and you're dividing them, you're gonna subtract exponents, all right? So this exponent for the x, when you don't see a number, is a 1, all right? So we're subtracting 1 minus 4 over 5. Because again, quotient rule means that whenever we're dividing, we're subtracting the numerator by the denominator, all right? So this 1 is the same as 1 over 1, and we're going to still use butterfly method. 1 times 5 is 5. Cross multiply this way first. 1 times 5 is 5. Cross multiply this way second. All right. 1 times 4 is 4, and we are subtracting. All right. So 5 minus 4 is 1. And can I simplify 1 over 5? No, I cannot. All right. And that is how you do all the different variations. All right. So again, guys, just like that.